Hello everyone, today we are going to solve 4 exercise out of 10 of our first optics assignment, and here number 5th equation. Let's read the given. After that we can see the figure below that illustrates the given of our fifth exercise, and here we have the first maximum till the 1. We have 1, 2, 3 peaks, and we can write our delta y by 1 over 3, and also here is centimeters, so 1 over 3 centimeters. After that, what we must find here? We must find what is the distance to the screen, and here we can already notice that we have amount of wavelengths, the distance between slits is already given, and by the formula, let's remember our main formula, which is known as delta y is equal to lambda times L over T. By this formula we can express L. It will be delta y times T over L or lambda, and here we can find it by putting their amounts, and the L will be by calculating 1.32 meters. Try to do exactly let's focus to accuracy and convert our units to what we need. And let's look to the second exercise. Here we have light sodium lamp given wavelengths illuminates 2 nanoslits. The range spacing on a screen is 100 centimeters, behind is 4 meters. And what is the spacing between 2 slits? We must find our main spacing, or the D. Okay, let's copy this question and let's look here, because we have here space, and what is already given here. The basic that is already given is our wavelengths. The first one is our wavelengths is already known as 1 minute 580 nanometers, and we also know the L it will be 100 centimeters, and delta y is already 4 times 10 power of 3 meters, and we must find D. What will be our D? Let's use exactly the same formula from exercise 5. It will be delta y times is equal to lambda times L over D, and let's express here D because we need the distance, and here it will be lambda times L over our y. As we already know what is y, what is L, and what is exactly the wavelengths, and after putting their amount and calculating, we best get answer 0.15 millimeters. Okay, I think that is enough, and let's go to the next exercise here. Exercise number 7. Number 7, let's copy the given, and after that let's put given here. Let's read the given. In double slit experiments, the slight separation is 250 times the wavelength of the light, and what is the angular separation degrees between two adjacent bright fringes? Okay, here we need I think that here we don't need to draw anything, because we already know the D. to just give it as 25 wavelets. And also we specified what is separation in degrees, so we specified the degree. Okay, let's remember our main formula where we have got 1 minute. I think that I put it wrong. What? Here, let's go to the number 9 exercise here. The figure below shows the light intensity on the screen behind the double screen. We have double slit here, and also the slit spacing is 0.2 millimeters, and the wavelength of the light is 620 nanometers. What is the distance from the slit to the screen? Okay, we must find what is the distance from the slit to the screen. I think that we already know about that, and let's look at the figure. Here we have already given our main 2 centimeters. Here the distance between our slits, and we can write it like delta y is equal to L/4. That will give us 1/2 centimeters. And also let's look at the delta y is equal to we remember our formula, the wavelengths times L/T, as we can express L here. It will be delta y times d over wavelengths, and by putting their amounts, we have here the amount of wavelengths, and also we have amount of d that expressed as 0.20. We can find our L that must be 1.61 meters. Okay, and let's solve the last question here. It is number 10. Figure above shows light of intensity behind a double slit. The slit is spacing 20 minutes on the screen. Okay, I think that we'll need this figure also. Here, I think that one figure for 2 exercises, and here we have okay, let's put here our exercise given, and the first one, what we have known, the slit spacing is delta 0.20 millimeters. It will be our d. It will be our d is equal to 0.20 millimeters, and our L is equal to 2 meters. And what we must find, it is what is the wavelength, and here we have condition that it must be in nanometers. Okay, let's remember our main formula. It will be delta y is equal to wavelength times lambda over d. That will give us the formula of wavelengths, that is also can be found as delta y times d over length. And here we can find by putting their amounts. It will be 0.5 times 10 minus 8 degree times 2.2 times 10 minus 9 degree. I'm sorry for my shift here, and also we can express this one, and it will be 5. We must find the nanometers, so I will convert 0.5 to 500 times 9 minus 10. Okay, minus 9 exactly, and it will give us nanometers. Okay, I think that this is enough for today's. Okay, and let's go to the next one, and here we must find it will be exactly nanometers. So this is the end of our exercise solving. Thank you for your participation. Goodbye.